A fish in an aquarium moves. You can say the work is done by a fish. Even me moving from that side to this side, I can just tell even I am doing some work. So that is all about a movement. Suppose you're considering the 3D. So it is three-dimensional figure. It is Z, which all three are perpendicular to each other. So according to second law of motion, we have force is equal to mass into acceleration. Hello everyone, I am Brinda, Faculty of Physics, welcoming you all to the session 1 of chapter 6, that is work, energy and power. So today in our concept, let us take just work, and I'll introduce this work for you in this concept class of session 1 chapter 6. So here, work. What is meant by work? So as you all know, in image you can see some work is done. When you look at a person who is walking over here, you will tell some work is done. Or else you're looking at the vehicles which is moving around, and you even can tell by looking at the image itself that the work is done. Again, a fish in an aquarium moves. You can say the work is done by a fish. Even me moving from that side to this side, I can just tell even I am doing some work. So that is all about a movement. So there is the displacement of an object when a force is exerted on it. Such an action is termed as work done. So the result of exhibiting the force on an object in order to displace it. So the object is said to be either at rest or it is said to be in uniform motion. You exert certain force on it so that the object gets displaced, and you can give a final result as the work is done by the object. So that is all about your work in general. So in this concept, first of all, let us study regarding the scalar product. So here, scalar product is also called as dot product. So here, instead of this for the multiplication, we use this, that is a dot product. Okay, so it is the method of multiplying two vectors. So we have seen the addition of vectors as well as subtraction of vectors, wherein the multiplication of vector has got two types. That is, one is cross product, another one is dot product. So this is the cross product and this is the dot product, that is multiplying method of multiplying the vectors. So now let us study regarding the scalar product. The scalar product is nothing but the dot products. So how it is given? There are two methods of multiplying the vectors, dot product and another one is cross product. What is that dot product? So consider two vectors A and B. So this is vector A and this is vector B. Then the scalar product of the dot product is given as, we have to find out the scalar product. This scalar product is also called as dot product. The scalar product or the dot product is given as the dot product of two vectors which is mentioned over here, vector A as well as vector B. So vector A into vector B gives you AB cos theta. It is mentioned as vector A dot vector B is equal to AB cos theta. So this is all about your dot product. Always it is, if it is vector P, if you are considering P vector and vector Q, so dot product of vector P and vector Q will be PQ cos theta. So the dot product always has cos as its function, cos theta as its function. So next, coming to the scalar product, here suppose you have got vector A and vector B, two vectors, and you have got this as AB cos theta, that is dot product of two vectors is equal to AB cos theta. You can write this as A into B cos theta. So if this is a case, we can say B is projected on A. The projection of B is given on A. So it is the projection of B is given on A. So these dotted lines is the projection of B on A. So this is at 90 degree. This is how you represent it. Suppose if it is in other case, that is B into A cos theta. The order has changed. B into A cos theta. Then it shows that this is your vector A and this is your vector B. A is getting projected on B. So projection of A on B at 90 degree here. So this is A cos theta. So now theta is the angle between two vectors. AB cos theta, this is a vector, cos it's a function, and theta is the angle between these two vectors. So that is all about your scalar product, or else it is also known as dot product, because the multiplication is taken place by just one dot. Okay, so next we are going to the same scalar product. We are just giving its condition, what it obeys, how it is applied for the unit vectors. So dot product obeys commutative law as well as distributive law. So what is this commutative law? It is like the order is misplaced. So we are giving different orders for the same set of vectors, and the result will be one and the same. The change in order doesn't change your results. Such kind of a property in mathematics is known as commutative property. So commutative property, A into B is equal to B into A. For example, 2 into 2 is equal to 2 into 2. 2 2s are 4, or else you can give it as 2 into 3. So you can just give it as 2 into 3 is 6. Again 3 into 2 is also 6. In multiplication, when you change the order, the result will be the same. Such kind of a property is called as the commutative properties. So your scalar product or the dot product obeys commutative law. And secondly, it is distributive law. That means it is getting distributed. There is distribution which is taking place. That is A into B plus C. You're distributing A for B as well as A for C. So A into B plus A into C. So that is all about your what does the scalar product obeys, which are the laws, that is commutative law as well as distributive properties. Next, scalar product or dot product in case of unit vectors. So what are these unit vectors? Unit vectors are the one which is having magnitude of unity. So in the case of your plane, that is motion in a plane, you had studied this is x-axis and this is y-axis, and the unit vector associated with x-axis and y-axis is given as I cap as well as j cap. Suppose you are considering a 3D. So it is three-dimensional figure. It is Z, which all three are perpendicular to each other, and this corresponds to K cap. So this is all about I, J as well as K. Having this 3D concept itself, we are just giving how the scalar product acts on I, J, K unit vectors. So when the similar unit vectors are multiplied with the dot product, you get 1. And when similar, that is J into J, similar unit vectors multiply, you get again 1. Similar unit vectors K into K, you get 1. When the unit vectors are multiplied with the other unit vectors, different unit vectors, then you have got 0 as your answer. That is, I is a separate unit vector, I, dot product of I and J, you get 0. Similarly, J and K is 0 and K and I is 0. So this is the concept which you have to remember, which will be useful, very, very useful in your solving numericals. So next, let us go to work energy theorem. Before that, what is that work? Yes, work is nothing but You're exerting force on an object and the force is responsible for an object to get displaced. So now, what is that energy? Energy is necessary for the work to be done, correct? So now you have got two kinds of energy, that is kinetic energy and potential energy. So you have got your energy wherein it is two types, kinetic energy and your potential energy. So potential energy is the stored form of energy. It's a stored energy before the work is done on an object. And kinetic energy is the one which comes along with the work done. So it acts along the work done. So this is how it goes. So here, what does your kinetic energy theorem states? The change in kinetic energy of a particle is equal to the work done on it by net force. So the change in the particle is just moving. So there is a displacement of a particle. So that is all about change in kinetic energy, right? So there is change, that is, for example, this is the waterfall. Every now and then I keep giving the example of waterfall because that is very much easier for you to understand. So the stored water here, it undergoes potential energy and the falling water undergoes the kinetic energy. So now the kinetic energy, as the water is let down, the kinetic energy keeps increasing and your potential energy decreases. Potential energy at this part, it is higher. As it moves down, it decreases and the kinetic energy increases. So that is what it is. That is change in kinetic energy. There is change in kinetic energy as a particle moves, which is equal to, when there is a movement of particle, what do we tell? The work is done on it. How can you say the work is done? When the net external forces acted upon it. So that is all about your work energy theorem. That is, change in kinetic energy of the particle is equal to the work done on it by net force. So how can we give the work energy theorem now? Consider the equation of motion of a rectilinear motion of an object. So suppose an object which is at rest, it is having mass m as well as it is at its initial velocity, that is a state of rest. So this is the rectilinear motion, a straight motion. And an object is said to be in motion when the force is applied on an object. So what happens? Your object travels and suppose, just consider this is your final position. So this will be your final velocity and the mass is the same, which doesn't change. So this is your initial position and that is your final position with initial velocity and final velocity. So now what is the displacement which it is taking? So the displacement is given as S. Okay, so same object is moving from one place to the other place. So this is the actual position of the body after certain time interval. So consider equation of motion. You have studied 3 equation of motion in a straight line chapter. So you have to recall those equation of motion. Of a rectilinear motion of an object under constant acceleration. So under constant acceleration, we have got a position velocity equation, that is v square minus u square is equal to 2as, where your v square is final velocity minus u square is your initial velocity, which is equal to 2 into acceleration into your displacement. So u and v are initial, final velocities, again distance which is traversed, as well as your a means it is acceleration. So now taking this equation 1 on multiplying both the sides of equation 1 by your m by 2. Okay, so consider equation 1, that is you have v square minus u square is equal to 2as. You're multiplying both the sides by m by 2. So you have got mv square by 2 minus mu square by 2, which is equal to 2 into a into s, and divided by 2. Again you have to multiply this with m. So 2 and 2 gets cancelled. So you just take your 1 by 2 outside, 1 by 2 mv square minus 1 by 2 mu square is equal to ma into s, that is ma into s. So mass into acceleration, it is all about force. So according to second law of motion, we have force is equal to mass into acceleration. So by that you have got half mv square. So half mv square is the formula for the kinetic energy. So what is your kinetic energy? Half mv square. So it will be kinetic energy of the final position minus kinetic energy of the initial position, because this is u and this is v. This is the final position and this is initial position. So it is final velocity, initial velocity. So kinetic energy for final velocity, kinetic energy for initial velocity. So it is Ke, that is kinetic energy. Subscript I have mentioned. So mass into acceleration is F and this is S. So change in kinetic energy. So this represents change in kinetic energy. So I can give it as, I'll just give it here. It will be change in kinetic energy is equal to force into the displacement which is taken place over here. So the force into displacement is mentioned as the work done. So you are giving the work energy theorem. So there should be an expression which contains work as well as energy. So energy, it is already here, that is kinetic energy. So change in kinetic energy is equal to the work done. So force into displacement, when you exert certain force on an object, the object starts moving. So exerting force on an object, the object starts moving. So we can say that work is done. So what is that work? Work is nothing but the product of force and displacement. So now you have got force into displacement is nothing but work done. So it will be delta Ke is equal to W. So final answer is delta of, that is change in kinetic energy is equal to the work done. So this theorem is an important theorem for your exam. So work energy theorem, and I hope you're clear with this work energy theorem, which is very important for your exam. So in our today's class, we had discussed regarding what is meant by work and dot product as well as cross product. Under that, we studied detailed about the dot product, which is also called as scalar product, and we found out what is that energy, work energy theorem, and we derived the expression for work energy theorem. And that's all for today. Let us see what comes next in our session 2. Until then, have a good day. Thank you.